Okay, hi, back again. We're going to start with question 7 from test 2. So it says 150 students are available. One student is selected at random. Which events are mutually exclusive? And so mutually exclusive events cannot occur at the same time. So of your choices, mutually exclusive, let me write that a little bit neater. Mutually exclusive events cannot occur at the same time. So you had choices choosing a woman and choosing a man. That's mutually exclusive because they cannot occur at the same time in this selection. Another possibility, which was not correct, was choosing a woman and choosing an engineering major because those could happen at the same time in 10 people. So they are not mutually exclusive. Another choice in that question, if you had that version, was choosing a man and choosing a non engineering major. Those could happen at the same time. So they are not mutually exclusive events. So your choice, if you had that question, the correct answer was choosing a woman and choosing a man, mutually exclusive. Another version of that question, of question 7, said which events are not mutually exclusive if you're choosing one person at random from those 150. And the correct answer of not mutually exclusive of the choices given, not mutually exclusive, was choosing a woman and a non-engineering major. Write that a little bit neater for you all. Choosing a woman and choosing a non-engineering major, those are not mutually exclusive because they could occur at the same time, and they did in 10 people. One of the incorrect choices for not mutually exclusive events was choosing a woman and choosing a man. Those could not happen at the same time, so they were mutually exclusive. The other incorrect choice for not mutually exclusive events that could happen at the same time is choosing an engineering major and choosing a non-engineering major. Those could not happen at the same time, so those are mutually exclusive. Could happen at the same time, so they are mutually exclusive events. So going to question 8. 150 students are surveyed. One student is chosen at random. Find the probability of choosing a woman. Write your answer as a decimal. So this is if you have 150 students, 35 engineering majors, 115 non-engineering majors, first two columns, 65 women, 85 men for the first two rows. And again, two different versions. So choosing a woman. Out of 150 people in total, there were 65 women if you, in the first row, if you had that version of the question. So if you take 65 divided by 150, 65 divided by 150, just to double check my answer, is 0.4333, repeating, rounding to 3 decimal places, 0.433. The other version of question 8 had 35 women, 115 men, and 65 women and 85 men, 35 engineering majors, 115 non-engineering majors. So same numbers, but this question was find the probability of choosing a non-engineering major. So out of 150 people, the probability of choosing a non-engineering major, the total of the second column is 115 over 150. By the way, this is empirical probability based on the results of a sample that was taken. And let me just double check my answers. And you're going to get 0.7666 repeating. So that's 0.767 when you round to 3 decimal places. Okay, so going to question 9. 150 students are chosen at random. Again, still 35 engineering, 150 non-engineering, 65 women, 85 men. Both versions of this question actually had the same table. But the question number 9, one version said, find the probability of choosing a woman or a man. So these are mutually exclusive. They cannot occur at the same time. So the shorter addition rule, or is the addition rule. So out of 150 people in total, the probability of choosing a woman, 65 from the first row out of 150. Or is the addition rule, out of 150 people, second row total, second row, 85 over 150 probability of choosing a man. Keep the common denominator of 150, add the numerators, you get 150 over 150. So your answer is 1. The other version of question 9 you might have gotten was find the probability of choosing an engineering major or a non-engineering major. Again, mutually exclusive events because they could not occur at the same time. So we just take the shorter addition rule, or is the addition rule. Out of 150, the probability of choosing an engineering major, first column, 35 over 150. Probability of choosing a non-engineering major, second column, 115 over 150, which gives you 150 over 150, which is an answer also of 1. Going to number 10. Two versions of number 10. Again, keeping with the same table of 65 women, 85 men, 35 engineering majors, 115 non-engineering majors. So one version of number 10 says, find the probability of choosing a man or a non-engineering major. So these could occur at the same time. So they are, that's not very clear. Let me write it a little bit neater. Man or non-engineering major. There you go. So these could occur at the same time. They are not mutually exclusive. So longer addition rule, where we have to add and subtract because we're double counting some of the outcomes. So the probability of choosing a man is second row, 85 over 150. Probability of choosing a non-engineering major, second column, 115 over 150. But we double counted the 60 male non-engineering majors with the males and again with the non-engineering majors. So we have to subtract that. So if we take 85 plus 115 gives you 200, minus 60 is going to give you 140 over 150. Dividing that out, we're going to get 0.9333 repeating, rounding to 3 decimal places, 0.933 for a man or non-engineering major. The other version of question 10 was find the probability of choosing a woman or an engineering major. So again, these could happen at the same time. They are not mutually exclusive. So we have to use the longer addition rule where we add and subtract. So the probability of a woman is the first row, 65 over 150. Probability of choosing an engineering major is the first column, 35 over 150. But again, we overcounted the 10 women who were engineering majors with the women and again with the engineering major. So we have to subtract the probability of a woman and an engineering major. That's a 10 there. And so this is going to give you 65 plus 35 is 100 minus 10. This is going to give you a 90 over 150. So when I divide that out, 0.6 exactly. So going to question 11 from test 2. Question 11 has two versions. The probability that a BCCC student is a Maryland native is 45%. So 0.45. So that means the probability that a BCCC student is not a Maryland native is 1 minus 0.45 or 100% minus 45%, which gives me 55% or 0.55. So question 11 says, if 3 BCCC students are selected at random, find the probability that all 3 are Maryland natives. Write your answer as a decimal. Okay, so we want the probability of 3 Maryland natives. So this means a Maryland native and a Maryland native and a Maryland native. So that's going to be, and is the multiplication rule. The easiest way is to just take our 0.45 to the power 3. Though even though they're selected without replacement, sorry, let me move that up. because I'm at the bottom here. Even though they're without replacement, the probability remains the same because we're only taking 3 people from all of the BCCC students. So if I put that in my calculator, I'm going to get this decimal, 0.0091 something. So rounding to 3 decimal places, very small, 0.009. Very small probability there. The other version, 0.0, wait a minute, let me try that again. Looked at my calculator wrong. Try that again. 0.0911 something. Try that again. So that's 0.091. Sorry, read that wrong. That's my right answer. Okay. So the other version of question 11 says find the probability again. So the probability that someone is a Maryland native, a BCCC student, is 55%. So that means the probability that someone is not a Maryland native in this version of the question is 1 minus 0.55, which is going to give you 0.45, or 100% minus 55% gives you 45%. And this question says, find the probability that if 3 students are selected at random, find the probability all 3 are Maryland natives. So we're going to take 3 Maryland natives. So a Maryland native and a Maryland native and a Maryland native. So we're going to take 0.55, and is the multiplication rule, to the 3rd power, which is going to give you 0.1663. So rounding to 3 decimal places, we're going to get our answer here of 0.166 for question 11. Question 12, let me try to get to that one before I run out of time here. So in question 12, one of the versions is probability someone is a Maryland native is 45%. That would mean that the probability someone is not a Maryland native is 55%. 1 minus 45% because they're complementary events. And so in question 12, it says 3 students are selected at random. Find the probability that none are Maryland natives. So that means 3 non-natives. So a non-native and a non-native and a non-native, and is the multiplication rule. So if we take 0.55 to the 3rd power, that's going to give you 0.1663, again rounding to 3 decimal places, 0.166. The other version of this question says the probability that a BCCC student is a Maryland native is 55%, 0.55. That would mean the probability that someone from BCCC is not a Maryland native would be 45%. 1 minus 0.55, complementary events, or 100% minus 55%. And this says 3 students are chosen at random. Find the probability that none of the 3 are Maryland natives. So we want the probability of 3, none of 3, 3 non-Maryland natives. None of 3 in the previous version too, by the way. So the probability someone is not a Maryland native is 0.55. So a non-native and a non-native and a non-native is 0.45 to the 3rd power, and is the multiplication rule. So 0.00, I have trouble with this particular decimal, 0.0911 something. So rounding to 3 decimal places, 0.091, if you got that version of the question. So I'm at 14 minutes. I'm going to stop here, and I'm going to pick up with question 13 on my next version, my next video.